The next our job is to plot the probability distribution function. I give this concept to you then, but I think everything dropped out of your mind, and that's why I remind you. So, probability mass function gives you mapping between value of random variable and its probability. What about probability distribution function? Probability distribution function, it has associated with two variables x's. We usually denote it like probability of x and x capital. It gives the probability of the event associated with x small, which is less or equal x capital. What does it mean? It's better it can be, and it's better to get to this concept with some example. For example, so for example, x capital equal 5. So for example, PDF 5x is a probability that of getting R, I put here R, of getting at most 5 successes. So it means that it is probability that we can have 0 successes 1, 2, 3 or 5. So we can calculate it adding the probability of the events then R is less or equal 5. So all of these chain of probabilities. Okay. And so that is about the concept of the probability distribution function. So to plot this graph for probability distribution function, we have to recalculate these numbers and make one more table. If you don't mind cleaning this part of the board, I want to make some recalculation. So the previous thing was probability mass function. We can denote it like for binomial distribution like P and chooses R, and we calculated it using this formula, and minus R raised R times P raised to power R Q raised to power and minus R. So we made this graph. I remind here the result of this thing. Here we have R, here we have probability mass function. And we have here, I put here the numbers which we calculated are here. Probability mass function R could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I write down them. I calculated them 0.197, 0.197, 0.347, 0.275, 0.129, 0.40, 0.8, 0.1, and we have here 0.1, and now we have something like 0.8 times 8 5 8, and here have 3 0.1 2 3 4 5 6 7, and 6 times 10 raised to power negative 9. So it means that we have 9 zeros after 0.0. I calculate everything here. I used Excel function calculate using this formula. Okay, now we have to plot the probability distribution function. Probability distribution function. I gave this concept of probability distribution function, but I think that everything dropped out of your mind, and I remind you, PDF function, what is it? Probability distribution function. I denote it like P of x. Here we have small x, I do not like smooth x, and it's associated with a capital X. Here, I first write down this denotation and then try to explain. It is the probability of getting result x less or equal x capital. What does it mean? For example, x equal 5. So this probability distribution function plot or sends any random x for our situation R. I put it here 10x, gives a probability that result of your experiment gives x which is less or equal 5. So this is the probability that result of your trial or your experiment can give 0, 1 or 5 or 3 or 4 or 5. So at most 5. So it means that x at most 5. Okay, and now we have to make the special table for the probability distribution function. Firstly, I have to make here by the less than, not For example, we have here, sorry, I have here R and here PDF, but probability distribution function. So probability distribution function. R can be less than 0, less than 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, it suits. Okay, what is the probability to get results less than 0? So it means that we have negative number of the successes. It's 0 because it's impossible to get negative number of any result. Less or but more than 0. When we get 0, the probability to get result less than 1 is given with 0.997. When we are getting the 2, the probability here, we have two events which satisfy the situation that x less than 2. They are 0 or 1. You remember that if we have the logic operation or between probability, we have to add them. So we have to add to 0.197 this number 0.347. According to my calculation, it is 0.544. 0.544. To make a hint of this calculation, I made here the equality. I want to make here an equality. It is 0.997 plus 0.347. And the same operation we have to make for each of these columns. We have to add 0.44, next one, this 0.75, and it gives the result 0.820. 820. Or in other words, it is 0.44 plus this 0.275. It's like a tip. And the same thing I have to make for 3, 4, 5. So I have to add new extra probability to previous result. And that's why sometimes people say the probability distribution function, probability cumulative function. So this is the same like probability cumulative function. The same thing. Probability cumulation. It is probability distribution function. Distribution function. And we can say it probability cumulative function. Probability cumulative function. So I want to write down here. We'll write it because 0.95, 0.998, 0.999, and step by step it's getting more close to the 1. According to my Excel calculation, because of round effect, it gives me 1 for all these columns, but really it's a little bit less than 1, and only the very last one gives 1. And here we have some numbers. Now we are ready to make this plot of this graph. I want to use this space. If you don't mind the cleaning, if you don't mind cleaning of this thing, I want to make it here. I want to. Okay. So x I put here R because we use R here. And here I have to put the probability distribution function. The maximum value is 1, is getting 1, it can be more than 1. Here I make a scale, step 1, 0.5. I make this scale 0 and step 0.1, 0.2. And here I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I'll make this plotting according to these numbers. When r is less than 0, x or r, probability distribution function or probability cumulative function is 0. So I stick it together with axis r. Then it's getting 1, it is 0.197. So it's about 0.2, so it goes here up to the 1. So I make these vertical lines here. It's these vertical lines, they facilitate our plotting. Less than 2, it is 0.54, so it's a bit more than 0.5. Put here. 0.3. It's about. I want to make these steps 1, 2, 3, 4. 0.9 here, 0.8 here. So we have 0.20. So a little bit more than 0.8, so it's getting here. And then we are getting closer and closer to the 1, 0.92 here, and then 0.5. Very close to 1, and getting closer and closer. But they are not still 1. And the very last, if we are more than 10, we have exactly 1, it goes to the infinity with the value 1. So here you have this stairs function. It is the probability distribution function. Distribution function. So today I showed you the way how we can make the probability distribution function, the probability mass function for given distribution. If you know the formula for probability, you can very easy to calculate everything. You can use your Excel, Microsoft Excel product to calculate if you can. Or you can use calculator to complete your individual work which are attached to your course. Okay. So, as a bottom line of today's lecture, I want to say that probability distribution function and probability mass function, either of them, completely specifies both of them completely specify the view of the distribution of and behavior of the variable. You can use either probability cumulative function or probability distributive function, and you can use both of them to define the expected value of your random variable. And next time we'll calculate some work using this binomial distribution. But I have a question. You remember this formula for probability distribution function? But I have a question. I want to clean everything here. By the way, everything, all these notes, I attach to this course. I make photo or print screen, and you can find everything in my course. I want to clean everything here. Надо будет немножко по-другому все это сделать чуть-чуть в следующий раз. Сейчас последний момент скажу и все, больше я ничего не записывал. So, I have the very last question for you. Look, the probability and r equal n factorial n minus r factorial alpha factorial p raised to power r q raised to power n minus r. This formula, we have reduced here this formula and choose this r, p raised to power r, q raised to power n minus r here. What happens if n is quite large number? Is a quite large number. For example, 200. How can we calculate n factorial? 200 factorial. So we can have more than 10 or 100. We can have 200 trials or 1,000 trials. And if you try to calculate factorials of 200, for example, using calculator, I think I have a very strong assumption that you will have an error. I try to do it using Excel. Hey, cat. Hi, how are you doing, cat? I want to calculate, for example, 200 here, run equal factorial. And it gives me error. So if you use calculator, a calculator gives error, gives zero. Excel, the program Excel is failure 2, which is disabled to calculate large ranged factorials. So how can we use this formula? This is the question to think about up to the next hour meeting, when I'll explain it, how to work with this situation, and we'll go into the normal distribution, because normal distribution is a sequence of the binomial distribution, then n tends to the infinity. When n tends to infinity, we have so-called normal distribution. And normal distribution, I think, is the essence of the math statistics. Okay, see you later.